Hello everyone, we are ready for science. This is Wednesday, April the 22nd, and we are talking today about mirrors and lenses. And this is page 248 in your book. This is the page that you should see. Please open it up and have it with me. You should also have out your activity manual page that looks like this, and it says Mirrors and Technology. Mirrors and Technology, and you've got the three pictures there right at the top. I want you to glance over that page quickly right now and look at what it is that we're going to be talking about and what you need to be listening for. I am going to look at the material with you, but I'm not going to be answering the questions like we have been doing the last couple of lessons. What I am wanting you to do in the comments today is comment below according to your number, so your class number. So who's number 1, who's number 2? So Nate's 1, Emma's 2. What's your number that you used to put on your page, okay? I want you to answer that question on the comments. So Nate would answer number 1. Leah would answer number 3. Since this only goes to 15, I want Riley to do question 2. And I want Maddox to do question 13. 13. Chase, you still to do 13 also, but Chase is coming to me through email. So Maddox will answer number 13, Riley answer number 2. And then in the comments, you're going to tell us what answer you got for each of, for the number that goes along with your class number. That's it. So you're each going to have one answer, and then we'll be able to see all the answers. Okay. All right. Now let's look at mirrors. Have you ever bounced a ball against a wall? Okay. So you bounce the ball, it comes right back at you. Light reflects off different surfaces in much the same way that a ball bounces. When light shines at an angle onto a smooth surface, the light bounces off at an equal angle in the opposite direction. If you watched the video links that I shared with you yesterday, then they talked about this. They talked about the angle of incidence when light comes in and bounces off. Mirrors reflect light in this way. When light shines on a rough or bumpy surface, the reflected light goes in many different directions. Some surfaces, such as paper, look smooth. However, if you use a microscope to look at a piece of paper, you will see that its surface is rough. So light that reflects off the paper will go in many different directions, and you see your illustrations there in your book. Rough surfaces, such as paper and snow, reflect light, but they do not make good mirrors because the light is not coming right back at me, so I can't see my image back. Mirror surfaces are shiny and smooth. A mirror is any surface that can reflect light to form an image or picture of an object. It's not just the mirror that you think of in your bathroom wall. Think about when we read Amos Fortune, and it was just like a piece of tin that was smooth that was used as a mirror. It wasn't like what we have now, but it reflected his image. A mirror with a flat surface is called a plane mirror. Not plane like ordinary, not plane like airplane. Plane as in flat. Like if you have a plane, that's an area or a surface. Most common mirrors, such as a bathroom mirror, are plane mirrors. A plane mirror shows an image that looks exactly like a real object. The only difference is the image is reversed. You may have noticed that the front of an ambulance has the word ambulance written backwards. This is so a person driving a car in front of an ambulance can look in the rearview mirror and read the word clearly. This lets the person quickly know to get out of the way. Some mirrors are curved. Curved mirrors change the way an image looks. They can make the image look larger or smaller than the object really is. You may have seen curved mirrors at a fair or an amusement park. The amount of curve can vary. Some mirrors curve a lot. Others have a curve so small that it may not even be noticeable. A mirror that is concave curves inward. So look at your picture down there at the bottom. And the way I try to remember, because these are two words that get really mixed up in a lot of people's minds. If you have a concave mirror, it's going in like a cave. Like if you were walking into a cave, it's curving in that way. Okay. These mirrors reflect light toward a point in front of the mirror. If you stand close to a concave mirror, your image is magnified or made larger. Many women and men use concave mirrors when they put on makeup or shave. This kind of mirror allows them to see better detail. Some telescopes use concave mirrors. These mirrors help faraway objects look bigger. A mirror that is convex curves outward, so it comes this way towards the person is a convex. So look at your picture down there at the bottom. So think about a spoon. One side is concave, then you turn it, and that's convex. These mirrors reflect light that spreads outward. Images seen in a convex mirror look smaller than the objects really are. And this would be a good chance. Go to your kitchen drawer and get a spoon, and you can see the difference when you look at the different sides of the spoon. Images seen in a convex mirror look smaller than the objects really are. You can use a convex mirror to help you see a large area. Many stores use convex mirrors to watch for shoplifters. And automobile side mirrors are convex mirrors. Now, the next page talks about light and technology. This is page 250, and we do need these 2 pages to answer the bottom 11 through 14 of your page. An X-ray machine is just one tool that has been developed from the study of light. We talked about the X-ray the other day. There are also many other inventions. See if you caught any of these. Many of you listed things that use light, but did you catch some of the things we're going to talk about? What do some telescopes, lasers, and cameras have in common? They use mirrors and lenses to change the direction of light. A lens is a piece of glass or other transparent object that refracts light and produces an image, so it breaks the light up. Telescopes help people see things that are far away, such as planets and stars. Some telescopes are small, others are huge. The Subaru telescope located in Hawaii weighs 555 tons. That might be cool to look that up and see if you can find a picture of it. That is more than the total weight of 56 buses. Regardless of size, however, all telescopes use mirrors or lenses or both to collect and bring the light to a point or focus. A reflecting telescope uses a concave mirror to gather and focus light. The light is reflected to the eyepiece lens, which magnifies the object. A refracting telescope usually uses 2 convex lenses. One lens gathers the light, the other magnifies the image. Cameras can also use mirrors and lenses. There are many kinds of cameras, though, and each works in a slightly different way. A single lens reflex camera uses a mirror, a lens, and a prism. Lasers use mirrors to produce a thin beam of light that is very powerful. This beam of light is only one color. Inside a laser tube is a medium for the light to travel through. This medium can be a gas, a liquid, or a solid. At each end of the tube is a mirror. As light travels back and forth through the medium, the mirrors reflect it. One of the mirrors in the laser is semi-transparent. It reflects some light and lets some light pass through. Some of the light leaks out of the tube through the mirror and produces the beam of light. The color of the laser depends on the type of medium that is used. Ruby lasers have a solid ruby rod inside the laser. These lasers give off red light. Other lasers with red light may use a gas instead of a ruby. Different gases can cause lasers to give off blue light or green light. Lasers can be found almost anywhere. DVD players and CD players use lasers to read the content of a disc. Checkout scanners in many stores use lasers to read barcodes. Doctors sometimes use lasers to perform delicate surgeries or to look inside a patient's body. Some lasers cut cheese into fancy shapes. That's cool. Others are powerful enough to cut through steel. Okay, so now I want you to look at your page, answer those questions based on what we read, and then according to your class number, give me that answer below.